Okay guys, so the beginning of calculus is all about just kind of relearning and reviewing some things that you learned in pre-calculus. So we're going to start off with trigonometry, and first of all you need to remember that pi is the same thing as 180 degrees. And so our first goal is we want to be able to convert angles from radians into degrees. The fastest way to do that is to literally count the pi as being 180. So what is 180 divided by 3? 60. So this is just 60 degrees. The reference angle is how far we are away from the x-axis. It's always the x-axis. So if I'm thinking of 60 degrees, how far away is it from the x-axis? 60 degrees. No, it's always... The reference angle also always has to be between 0 and 90, okay? So the reference angle for pi over 3 is still going to just be 60 degrees. All right, what about pi over 6? What's another name for pi over 6? 30 degrees. 30 degrees, how far away is that going to be from the x-axis? 30 degrees. So the reference angle is going to be 30 degrees also. Okay? Pi over 4. Guys, if you're going to divide by 4, the easier way to do it is to divide by 2 twice. So what's 180 divided by 2? And then divide by 2 again. So pi over 4 is going to be 45 degrees. And again, of course, that's going to be reference angle of 45 degrees. So these are going to be other names for those angles in degrees rather than radians. When you're doing this type, don't do 2 times 180 first. Let's go ahead and do 180 divided by 3. What's that? 60, and then times 2. So what's this going to be? 120. But what's the reference angle for this one? It has to be between 0 and 90. How far away is 120 from 180? 60 would be the reference angle. Okay, go ahead and figure these two out. So what about this one? What's 180 divided by 2? 90 times 3 is 270. This is a special angle. It's quadrantal. When we have quadrantal, there is no reference angle. All right. 7 pi over 4, what was 180 divided by 4? 45, and then 45 times 7. 315, good. And then what's the reference angle for that? 45, good. Okay, now we're going to go the other way. This way is a little bit easier than going in this direction. But the fastest way to do this is to first of all find the original angle. Actually, let's do this. We're going to find the reference angle in degrees. Once we know that, then we can figure out what this is in radians. So what's the reference angle? How far is it from 150 to 180? And so what's 30 degrees? Pi over 6. So this is 30. 30 times what is 150? So this is 5 pi over 6. That's the fast way to convert. Of course you can multiply by pi over 180 and then reduce the fraction, but I just think this is a lot faster. 240, how far away is it from 180? So what's 60? Pi over 3. And then what, 60 times what's 240? 4 pi over 3 is what this would be. 315, what's the reference angle? 45. 45 is pi over 4. Now look, if I'm doing 315, there's 1, 45, 2, 3, 4, 5, 6, 7, right? So 7 pi over 4. And then finally we already did 270. Do you remember what 270 was? What was it? 3 pi over 2. Okay, on to SOHCAHTOA. So SOHCAHTOA helps us to remember the trig ratios. You also need to remember that opposite means the same thing as the y value. Adjacent also means x, and the hypotenuse can also mean r if we're thinking of a circle. So what is sine going to be? O over h, right? So our angles for trig always have to be here at the origin. So this would be my theta, or this could be my theta, depending on the quadrant. With respect to this angle theta, this is opposite, this is adjacent, and this is hypotenuse. For this angle, this is opposite, this is adjacent, this is hypotenuse. So when I'm looking at this angle right here, this is opposite, but it's also a y value. See how that would be the y side of the triangle? So we're going to think of this as y over. And then if I had a circle going around this triangle, that hypotenuse would be the same thing as the radius. So sine theta can also be thought of as y over r. Cosecant is always going to be the reciprocal, so it's h over o, or it can be r over y. Cosine, of course, is adjacent over hypotenuse, which is also x over r. Secant is the reciprocal, so I can think of it as h over a or r over x. The last two we have are tangent and cotangent. Tangent's going to be opposite over adjacent, which is y over x. Cotangent's going to be adjacent over opposite, which is x over y. All right. The next thing we have to know to do trigonometry is the sides of a 30, 60, 90 triangle. That could be our 30 degrees, this is our 60 degrees, this is our 90 degrees. Does anyone remember the relationship between the 30, 60, 90? How's it go, Anna?
Across from 30 is x, hypotenuse is, I think, 2x, and then it's x radical 3.
Good. And we don't really have to use the x's. Sometimes x's just kind of get in our way. So instead of calling this x, I'm just going to call it 1. And I'm going to get rid of this x and this x. So I'm just going to use numbers. It always goes in this ratio. 1 radical 3, 2. 2, 2 radical 3, 4. 5, 5 radical 3, 10. It always has that relationship. What about for 45, 45 90s? Anybody remember? How's it go, Jasmine?
Or no. Oh God, I don't remember.
Well, what's true of the legs? They're always going to be what? The same. If you don't remember, guys, you can think of a square. So what if I call this 1, 1, 1, 1, and then I drop this across here? So to find this side, I would do a squared plus b squared equals c squared. So what's it going to be then? If this is 1 and 1, what's that hypotenuse going to be? Radical 2, and that's the relationship, 1, 1, radical 2. All right, so these triangles help us to do trig. I know that a lot of you memorized the unit circle last year, and you were fine with that, but I've always found that when you have summer and you've relaxed a little bit, it's kind of hard to remember the unit circle from last year, the whole thing. So I'm going to show you another way to do it. As long as you know these two triangles, you can do all these problems. And you can do these problems down here, just by knowing those two triangles. So what we can do is, we're going to draw a picture of this angle. I'm trying to find the relationship of the opposite over the hypotenuse. So 330 starts here, there's 90, 180, 270, here's 330. How far away is that from the x-axis? Oh, 30, yep, 30. So this is going to be my reference angle here, 30. What goes across from the 30? What number? 1. Across from the 90 is 2, and this is radical 3. Now I want to make sure this x is in the positive direction, this y is in the negative direction. So if I'm trying to find the sine of 330, it's going to be opposite over hypotenuse, or y over r. So that value is negative 1/2. Now if you can remember that from the unit circle, great, more power to you. You don't have to draw the triangles or anything like that. If I wanted to check this, I could do so on the calculator, all I have to do is make sure that my calculator is in the correct mode, which is degrees, and I can do the sine of 330, get that answer, and then I can math frac it just to check, negative 1/2. Okay? All right, tangent of 300. 390, which quadrant, guys? Fourth quadrant. What's the reference here? 60. Label those sides. Make sure you know whether they're positive or negative. And then figure out what would the tangent be. Aubriana, what is it? Do you have it? Okay. What is it going to be, Rachel?
Negative radical 3.
Yes, negative radical 3. And that's because I look at my reference angle and we do opposite over adjacent. And so that's going to give us negative radical 3 over 1, which is just negative radical 3. Okay? Cosecant of 5 pi over 4. Reference angle's what? 45. And I need 5 of them. So here's 1 45, 2 45, 3, 4, 5 45s puts us down here. Here's our reference angle. For 45, 45, 90s, those sides go 1, 1, radical 2. But then I have to look. This x is in the negative direction. This y is in the negative direction. The hypotenuse is always positive. The radius is always positive, and that's because this is just defined as distance, whereas this is actually directional as well. Cosecant is always going to be r over y. So do you know what it would be? Negative radical 2. Good. Now this one is pretty difficult to check. Let me just remind you how to check it. First, I'd have to go to my mode. I'd have to be in radians. And then to find this answer, I would have to do 1 divided by the sine of 5 pi over 4. And it would give me this answer. And I'm like, I'm not sure about that. Well, now I would just type in negative radical 2. Oh, okay. Yep, they're the same, aren't they? So therefore, it's correct. I allow you to use your calculators on all the trig, but if I ask you for the exact answer, you must give me this. Why is this not correct, even if you wrote that whole thing? Yeah. Yes, this is rounded. This is an irrational number that goes on forever. This is the only way to write it exact. Okay? All right, letter D. Reference angle. Kabir, do you know the reference angle? How far it is from 180? 30. So I'm going to be 150 is going to be in the second quadrant with a 30-degree reference. Do it on your own. Who's got it? What's it going to be, Jasmine? Yes. Cotangent, not tangent. I'm sure some people may have put 1 over negative radical 3, but it's going to be x over y. All right, secant of 3 pi over 4. Lauren, can you tell me which quadrant that's in? Second quadrant. Do you know the reference angle? Correct. So it's going to go 1, 1, radical 2. I got to look at the direction. The x is in the negative direction. Y is in the positive direction. R is always going to be positive. Secant. I have to think of my ratios. Secant's going to be r over x. So we're going to have to do hypotenuse over the x value. Brady, do you know what it would be then? You got it. All right, this one's kind of tough. When we see it written like this, guys, this means we have to find the sine of 2 pi over 3 and then square it. So 2 pi over 3, anybody know that in degrees? 120, got a 60-degree reference, got radical 3, 1, that's negative, that's going to be 2. So we have to do the sine of 2 pi over 3. What's that going to be? And then we have to square it. We've got radical 3 over 2. We've got to square that. Good. And then we've got to do cosine of 2 pi over 3. What's that going to be? Negative 1/2. Good. And then we're going to have to square it. And so what's that going to become? So that's going to be 2/4 or 1/2. Okay. Quadrantal angles. How in the world do we find the cosine and the tangent if we have quadrantals? Well, the only way to do quadrantals are those that are on the axes, and the only way to find the trig ratios on these without a calculator is to use the unit circle. You have to on these. So I think of the radius as being 1. Here's the origin. This point right here is over 1, up and down 0. This point right here is over 0, up 1. So what's this point right here going to be? You got it. And then finally this one. So if I want to find the cosine of 3 pi over 2, that's going to be 270. Cosine is going to be x over r. So what's it going to be? What is it, you guys? 0. For the tangent of pi, I have to go to pi, which is right here at 180, and I'm going to have to do y over x. Y over x. And so what's the tangent of pi going to be? 0. And if I just wanted to make sure real quick, I'm in radians, I believe. Tangent of pi, check it out, that's 0. Good. For the quadrantals, guys, there are only 4 possible answers we could get for any quadrantal trig ratio. You might know what the 4 possibilities would be. 0 is one of them. What else? Undefined. Good. You got it. Those are the only 4 possibilities. So if you have one of those quadrantals, never put anything else except for 0, undefined, 1, or negative 1. Okay, last part here. Finding angles in degrees if we have an equation. All right, so I'm not going to go through the steps. I'm just going to explain it as we go. This is asking us, where is it, what angle is it that would have a sine ratio of negative radical 3 over 2? We can draw pictures to help us with this. Of course, the unit circle is great. If you know it right off, perfect. Does anybody know it right off, though? Okay, that's what I thought. So we're going to draw a picture here. Negative radical 3 over 2. Y is going to have to be the negative because the r has to be positive. Which quadrant is going to have y as negative? 3 and 4. So we're going to have y as negative, so we're going to have to be here and here. The y is negative radical 3, the r is 2. The y has to be, remember here's the angles we're trying to find, the y has to be negative radical 3, the r has to be 2. What are we missing? What number out of the triangles? The 1s. Those really don't matter though. What's across from the radical 3? 60. I'm trying to find the answers between 0 and 360, so I'm talking degrees. So what's this one going to be? 180 plus 60 is what? 240. And then the other answer is going to be 360 minus 60. What's that going to be? 300. Now I want to show you something because a lot of times people are like, why can't I just do that on the calculator? But look at what the calculator does. If I do second sine of negative radical 3 over 2. Oops, I also need to be in degrees. But watch what it gives me. Negative 60. Is negative 60 in between 0 and 360? No. So it's giving me the answer from here going in this direction. So all it's telling me is really that reference angle. It's trying to tell me this answer, but I have to have the answers between 0 and 360. So that's not really as helpful. But if you understand trig, you'll know that it's just going in that direction rather than going around this way. Okay, letter B. If I have cosecant squared, I have to get the theta by itself, so I'm going to have to take the square root of both sides. What do we put in front when we have taken the square root? Plus or minus. Cosecant is going to be r over y. Can my r value be negative? No, so it has to be that the y is actually the plus or minus. Which quadrants would have positive and negative y's? All of them. I have to be in this quadrant, this quadrant, this quadrant, this quadrant. The y can be positive 1 or it can be negative 1. Always going to that x-axis when I draw the triangles. The r values have to be radical 2, bless you. What's going to be the reference angle if I have a 1 and a radical 2? Go back up here. Which one is it? It's going to be 45, isn't it? So I have to do 45 degrees in every quadrant for theta. Does anyone think they can do that? Tell me all of the 45 in every quadrant. Cooper, you got it?
That would be 45, 135, 225, and 360.
Very good. All right. And we are going to have you guys do C and D on your own. We're going to stop there and I'm going to walk around and check and see if you can get those.